आगे नहीं आगे नहीं कर तुम्हारा है हो गया
yes please.
Welcome back, folks. Now get ready for the informative talk by Professor Abhijit Mukherjee. He is Professor, Department of Geology and Geophysics from School of Environmental Science and Engineering at IIT Kharagpur. He will be talking about delineating groundwater security of India, where science meets policy. So, without further ado, I invite him on stage. Also, I would like to call Professor Arundhati Khattak ma'am to welcome him on stage.
Sir, you can just.
Yes,
Can we
start?
So you want hand mic?
Yes. A very good morning.
you can keep it on the project. Yeah.
Sir, this mic will work because you need to keep that off so that.
That's what I'm wondering. Am I audible?
Yes, sir.
You
used to teach in large classrooms. A very good morning, and this is my first visit to Azhar Bhopal, and it's a distinct pleasure, specifically, I see Professor Kailan after a long time. I have a lot of respect and I learned a lot from him at one time. Ashish is here who invited me. Thanks, Ashish. Um, so I got a chance to, mentor Ashish and people space time. Um, so I'll be talking about, groundwater for future of South Asia, specifically on the Indian subcontinent. And what I'll be talking about is the interface between science and human practices and how policy interventions can influence groundwater policies. So before we go for the presentation, I would like to definitely acknowledge my collaborators rather than going for each slide. I'll just talk about the various agencies that we have worked together, and some of the things that I'll be showing here is actually the outcome of about 20 years of work that we have been doing in the Indian subcontinent with all these partners. All right. So groundwater installation. Now we have a lot of discussion on groundwater, and it's one of the essential resource, not only from a geologic perspective or earth science perspective, but also from the domain of economics to food security and so on. And we feel like the knowledge of groundwater is something which is very new. Whereas the reality is that groundwater is something that is possibly was known to people in South Asia from a very long time. And as you can see, the picture on the top is a motif from like one of the temples, one of the Terracotta temples in Bengal, which depicts the scene of Mahabharata. The Battle of Mahabharata in Kurukshetra, where the great grandfather Bhishma is lying on the arrowhead, and Arjuna is piercing the ground to give out water. Well, it's a metaphor, but it's groundwater. Now, if this is a myth, or this is a legend, or history, I don't know, there is ample example in the scientific history of Indian subcontinent where groundwater has been used as a resource. We can start with the town of Mohenjo-daro, the Indus Valley civilization town, which has a record of more than 800 divers of groundwater. It's called the city of wells. And from there on to like across the history of India, you would see there are these examples of use of groundwater in making the history of India. So it is not something that is new to us. Possibly what is new is to understand it in its future time at the present place. So if you fast forward the use of groundwater from a historical perspective to modern South Asia, we'll see that groundwater is used in every sector of our life as of today. And that includes from food security to drinking water, to our domestic needs, to industrial production, to urban development, and so on. So yes, people think when we say groundwater, okay, it's water for drinking. Like Ashish just gave you the water. But it's just not drinking. And the reality is that if we do a reality check on the usage of groundwater, it's actually hooping 85% or more of the groundwater. It says water there, but it's mostly groundwater that is being used for food production. So actually drinking water consumption of groundwater is less than even 6%. So it's more the food security than the water security that we are concerned about when we are talking about groundwater. So what are the issues of groundwater in South Asia? Now, in today's time, there are a lot of people who are working on groundwater, and I'm sure there are students and colleagues here who are working on it. But before we go in the studies themselves, we need to understand what are the issues. And these issues start with water scarcity. And as the summer months are coming through in 2 months, you will see these kind of images in the media all the time. And people would be dying and suffering from water scarcity across the country. In older days, not tool, like just 10 years back. It was more of a picture that's coming from the more water scarce western part of the country. But in today's time, we also see this in the eastern part of the country, in the water affluent eastern part of the country. So the water scarcity issues are actually propagating with time. But then we have water resource too. Almost the same time, or maybe 1 month plus minus, when we have water scarcity across different parts of South Asia, we also have water excess. Now, the common notion is when you have water excess or flood, it's a meteorological thing. It's because of rainfall. But the reality is, if you are aware of the hydrodynamics, much of the flood actually is caused by groundwater. Okay, it's a couple system, and yes, it gets triggered by the meteorological factors, but it's contributed by the groundwater. So yes, so if you have water scarcity in one place, you also can have water excess in other places. But whatever, it eventually translates to the drinking water security issues. You would not have drinking water security either way if you have scarcity or excess. And that entitles us to secure our drinking water source as well as water sources for the future of our country. But then it cannot go away with the quality. Okay? And even if you have sufficient quantity of water, you can have just that quality of water. And this photograph I didn't take from Google, I shot it myself. It's from a field of people suffering from just drinking bad water. These are photographs very close to where Ashik is facing. People just drinking bad groundwater, contaminated with arsenic. And it's a geogenic problem, and nowadays also there are anthropogenic issues. So by and large, combining all these factors, the study of groundwater becomes immensely important in hydrogeologic phenomena, in hydrogeologic domain for the years to come. And then we didn't forget about climate change. Now, I'm not a climate change expert. I don't claim to be. However, I do understand it's a wide elephant in the room. And honestly, I personally feel that most of us don't understand what climate change is and how it's going to have an impact. We're all talking about, we're arguing like what may be the impact, but what exactly it will do, we don't know. But we definitely do know that if it's happening or will be happening, the first victim of climate change will be the hydrological cycle. And if that happens, definitely each of these issues that I talked about is going to get multiplied. So things are going to get worse, not better. This is more true as we are nearing the year 2030, and as many of you will be knowing that this is the year of the Sustainable Development Goals, achieving the Sustainable Development Goals of the UN. Goal number 6 talks explicitly on access to clean water and sanitation. Besides everything else, from poverty to hunger to clean energy and so on, goal number 6 is dedicated to just access to clean water and sanitation. And if you look carefully, each of the other 16 goals of the 17 are actually also linked with goal number 6. So it's not something in silos. Like we have issues that are inherent to access to clean water, and that's where the importance of valuing groundwater comes in present times. Now, why we have been talking about groundwater? Like, okay, the issues are there, but that's true for many other countries. Well, the matter of fact is that in the last about 50 years now, there has been quite some literature on the vanishing groundwater of India. It has been found even that there is a groundwater glut that is happening in the subsurface. So India is one such country which has become the paradigm in the planet, and it is possibly, beside the US, one of the most studied groundwater, and Bangladesh, of course, groundwater domains of this planet. So what we have been doing in the last about 20 years, but more focused last 20 years that I have been at IT Kharagpur, to learn how much state groundwater is available in South Asia and what is the future. And I would definitely like to, kind of highlight what's safe here. Okay, so what is the emergency? Well, the emergency is that South Asia or the Indian subcontinent sometimes it's kind of not same, but it's similar. If you go by the statistics, it covers about 3% of the global land cover, but then it hosts about 23% of the global population and more than 30% of the global irrigated land. Now, you are all, people of science here. So I don't think I have to tell you that this is not a sustainable situation. You cannot host almost like quarter of the global population, if not more, in 3% of the land and have 30% of the global production. So the factor is it came with the cost. It came that India or the subcontinent is the largest consumer of groundwater in this planet as of the day. So if I look at the statistics that was published by the good friend Richard Taylor in 2014, where he showed the historical to the future predicted groundwater usage in the most prominent groundwater user countries, you see that India is a leader, and of these days, the second and the third countries which are using a lot of groundwater, which is China and US, even if you add them up, they are nowhere close to India. So India is the leader and will be the leader for the few times to come. And why so? Well, if you look at this map, which is the map of the Indus Ganges Brahmaputra basin, or also known as Northern Indian Plains, you would see that there are these areas which are kind of I don't know if you can see properly here. So these are irrigation, groundwater irrigation color coded. So maroon is intensely irrigated and followed by the other colors. There is only one place in this planet where it is permanently maroon and red, which is the North Indian Plains. And there are some other states, but this is one place where you do have the maximum groundwater usage for irrigation and food production. So what we might conclude is that present day, India is the largest user of groundwater in the human history. It's just not in the present times, but possibly, the time of 5,000 years of human, or 5,000 plus years of human history that we're aware of. This is the first time that a country, a nation, is using as much of a geological resource as we are doing for groundwater today. Now, that's fine. So that's good for intro, but then we have to understand this is the Department of Earth Science, right? Earth and Environmental Science. So we need to understand the geology and the hydrogeology. So I'm showing you two maps that we kind of published about 7 years now, 8 years. But the left map is showing you the major groundwater provinces across Indian subcontinent or South Asia. And what you would see that there are two prominent provinces. One is the light blue Indus Ganges Brahmaputra basin, and then there is a deep blue, which is the Indian Cratonic or crystalline rivers. Now, these are the two major groundwater provinces across South Asia. Of these, the bright blue ones, the IGB or Indus Ganges Brahmaputra basin, or IGBA actually, Indus Ganges Brahmaputra and Meghna basin, it covers about 21% of the land cover of the subcontinent, but holds 70% of the groundwater reserve. Whereas the dark blue one, the dark blue province, which is a crystalline province, that has a land coverage of about 70% of the subcontinent. However, hosts only 20% of the groundwater reserve. So you can immediately see that there is a distinct polarization on the reserve itself, and it's no wonder that the IGBM is regarded as one of the most prolific groundwater systems in the world, and it is also one of the most intensely used groundwater systems in the world. Now, it also tells you that this IGBM aquifer system also do have a lot of groundwater, but is it so? Is it usable? Well, the map in the right shows you the geogenic pollution, and what you see that there is blue and the yellow color, which indicates the presence of arsenic and fluoride. You see that these are almost present. They are actually present. The arsenic is actually present in the North Indian plains, and fluid is just on the banks. The groundwater, if present, are actually fairly well contaminated by this geologic pollution. And present estimate shows that somewhere between 250 million to 450 million people are actually impacted or exposed to this kind of groundwater pollution. And to understand this groundwater pollution, we need to understand the groundwater flow dynamics, where you do have the research processes. Then you have what we call aquifer groundwater interaction, followed up by the research processes. And to understand the hydrogeology in more detailed sense, what we do is to understand each of these processes in further details. And of course, we cannot go away without climate change and human practices. Now, we have a tendency as geologists to think art minus human, but the reality is it's art plus human. So, just as of last year, 2023, US Geological Survey has revised their new, they have this map of hydrological cycle that they have been publishing for the last 50 years plus. They have revised it and put human in the picture. So yes, we cannot, go away from the human practices or policy interventions when you talk about a resource like groundwater. So this is, by and large, the map of groundwater research of India for about 20 years, from 1996 to 2015, that we published from study across India. Now, of course, the Jammu, Kashmir, and other part is part of India, but we didn't have data to calculate the research. So, but we show it for the rest of the part. And what you do see that there are interannual variabilities. It's not same for every year, and there are different hydrogeological reasons for that variability. And then there are these interaction processes in the subsurface, which would eventually modify the chemistry of the groundwater. The interactions would result to what we call the evolution of groundwater, and eventually can result, it would eventually result in the quality of groundwater, including the pollution. So we need to understand that as we go through. And I know Ashish, and through his phase work, I think one of the pictures is from his phase work, where we studied, and other colleagues studied the interaction of the fine grained sediments and organic matters with the groundwater to bring out the pollutants. But like I said, it's not without the human interventions. And if you are talking about pollution, yes, pollution is geogenic, and the arsenic and fluoride. It's a geogenic pollution, but not without the impact of human practices. And we have this general understanding nowadays that in addition to the geogenic processes that are happening in the subsurface that are eventually guiding the pollution, it is also the human practices in terms of how we are using our groundwater actually is proliferating the pollution in the subsurface. So I'm showing you the first ever published map of the arsenic pollution in the subcontinent. In India, across India, and what you do see that there are distinct patterns where the arsenic resides. And I can tell you, without going into further details, that in a larger scale, in a more broader country scale, or subcontinental scale, these orientation of the existence of these geological pollutants are totally geologically controlled. It would not be too much if I say that they are technically controlled. And then there are emerging pollutants. So as much we talked about the geological pollutants, there are also these emerging pollutants like pesticides and PHs that would be polluting and is polluting the groundwater of across India, specifically the Ganga basin. And lastly, to pollution, something that we try to turn a blind eye to is the fecal coliform in the groundwater. And in a shorter time period, fecal coliform is possibly more harmful than any of the other pollutants that I just talked about. Because if you drink bad water, this glass of water with some fecal coliform, I'm going to get sick by a couple of hours. Okay? and people do suffer from acute diarrhea to typhoid and other gastroenteric diseases. And estimates shows that at least 1 million kids across the world dies because of this fecal coliform pollution in groundwater across the planet. And one of the hotspots are actually in India. And many of the government missions that are in practice as of today are actually, in a sense, trying to stop this fecal coliform pollution of the groundwater. So what I'm showing you is the map of acute diarrheal cases as an impact of fecal coliform pollution for the last about 20 years, 25 years, that has been mapped across India. Now, what we do also get to see, like I told you, that it also shows us that the sanitation measures that are being taken by the government agencies are showing initial results, and there are a decreasing trends of this fecal coliform pollution of groundwater as I stand here today. So that's more of an intro. Now, what is the work that we have been doing? And groundwater is a more recent branch of geoscience. Now, people have been talking about groundwater for thousands of years, but the modern geoscience learning of groundwater is no older than 1960s. Okay? So, other than other branches of geoscience, modern hydrogeoscience started in the 1960s. So it is, it's just about 50, 60 years that we have been, studying the groundwater processes. Consequently, there is no exact, cookbook for study of groundwater. And we do apply all branches of geoscience as it requires to understand the groundwater systems. And what we have been doing in our group is to understand the groundwater by subsurface exploration, deep exploration, by in both these cases, drilling, either shallow or deep, earth observation and remote sensing. We do intense geophysics, piezometry, or hydraulics, then hydrogeochemistry, river water pollution and river hydrology to understand the groundwater interactions, and no less into this time integrating all this data in modeling AI and big data analytics. Now, I know AI and big data analytics are the buzzword for the day, but just like I was telling us Mr. Beginning, that yes, it's a buzzword, but it's a tool to be used with caution because it can show you things which does not exist. And it's immensely important that you understand the inherent science to make any outcome, make any comment on the outcome of AI and big data analytics. So let me show you a case study. And with all these things that we talked about, so we have been working in all these other domains. But I thought for today's talk, it would be nice to talk about one case study that you can take a take-home message. So this is a work that I've been doing with NASA since last about 12 years now, and so we are the Indian partner of NASA, and we have been a partner of this GRACE mission that NASA has been running from 2002. So I was fortunate to get introduced to the mission back in 2005 2006, as my DDM postdoctoral supervisor was one of the PI of the project. And as the mission says that there are two satellites, Tom and Jerry, and they are about 220 kilometers apart, and they are continuously circling us. So from 2002, it was initially estimated for 5 years, but the mission is still going on. Okay, it's more than like 12 years, sorry, 22 years now. The mission is still going on, and we have found immense data set, never seen before data set that we have acquired from this mission. And these two satellites, what they are doing is basically measuring the gravity of the planet in a microscale, very short time period. So as the principle works, that unless you have a catastrophe or some kind of catastrophic geological event, the gravity of a unit surface area of the Earth, they're changing all the time. And if they're changing in a short period of time, and unless there is a catastrophe, you can calculate that change back to hydrological mass transfer. And if you have the values for, let's say, snow melt and surface runoff and surface soil moisture, you can actually calculate out the groundwater storage change. Now, the groundwater storage is changing all the time, and like we geologists believe that things change in thousands to millions of years, groundwater changes in seconds. Okay, so there is a constant change of the dynamics in the groundwater systems, and these GRACE mission actually, opened our eyes to this change on a global scale in the last 22 years, including the ice sheets in the poles. Now, this is Earth observation, and there are cases. I'm sure that all of us understand that remote sensing data sets are good as much they are, but they have been to be validated. So, what we have been working with the government of India, the central government of both, and other agencies is to ground validate this data set. And with a lot of work, we were actually able to reasonably ground truth this GRACE data set with the groundwater measure data set from the ground, from the central government observatory systems. And we did find that there was a reasonable correlation. So this map shows you the bidecadal groundwater level trends as calculated out from the central groundwater data sets. So we initially took about 20,000 locations for 20 years of data, and we counted back to about 4,000 locations. And what we are seeing is the blue areas are areas where we have increase of groundwater over this 20 years period. The red area is where there is decrease of groundwater. And I'm sure that you can see some patterns, and we'll talk about the patterns in a minute. So this is the digital groundwater storage change calculated from the GRACE mission. And what you are looking at are how the groundwater is having internal variabilities, but even integrating the internal variabilities, you possibly can also see some long-term variabilities. So let's look at it. Right, so I'm sure that you saw this color, right? What is this color mean? Well, blue is good, red is bad. Blue means you have more groundwater, red means you have groundwater depletion. So if I look carefully, I'm sure you can see that the North Indian plains or the Indus Ganges Brahmaputra Meghna basin has actually been depleting quite fast. Even in the last 10 years, sorry, about 20 years now, the groundwater has receded substantially. Whereas the interesting fact is that there are some increase of groundwater in areas where we did not expect it. So places which are known to be more groundwater scarce, including where I'm standing today, actually showed groundwater rise in the last 20 years. Now this is, I know it's it's kind of against what we believe, but it's a reality. So this is the digital time series datasets of groundwater storage change across India. And if I classify the country according to hydroclimatic zones, so we have North, West, Central, East, and South India, 5 regions. And what we do see that the northern and the eastern region are having substantial groundwater depletion. Now, whenever we talk about groundwater, at least in terms of quantity, people always jump into for Punjab and Haryana. Yes, those are the areas where we did have a lot of groundwater depletion in recent times, but actually it's the eastern and northeastern India where maximum groundwater depletion is happening as of the day. It's not Punjab and Haryana as we used to believe. It has, but eastern India is actually the new player in the block. In contrast, if you look at the trends of West, Central, and South India, there is actually a positive trend, which suggests that even if low, there is a reversal of groundwater storage in these areas. So let's explore those a little bit. So if I take out all these noises, we can come up with these two maps. The blue one showing the groundwater storage increase, which you can see that some of these blocks are possibly from the locality in Bhopal and surrounding areas. And you have the red map, which are showing the areas of groundwater depletion. And the North Indian plains, including the western and eastern parts of India and northeastern parts of India, are showing severe trends of groundwater storage decrease. So can you call it a groundwater drought? Well, if so, if we can, if it's a persistent process. So then what is the cause? Well, the cause is definitely human practices. So it is back in the 1980s, actually 1970s, but more prominent in the 1980s, that high-yielding crops were introduced in South Asia. And like we are going through this farmer agitation now, but this has a history, and this history goes back to the early days of the Green Revolution, when high-yielding crops were introduced to South Asia, specifically to India, to ease out the food insecurity of the country. But it also needed extensive cultivation. Most of the paddy cultivation that we do in this country are actually through cultivation. And also that in more recent times, we have conversion of food crop to cash crop. And in many parts of, if you go to Western UP and so on, you would see that many of the rice paddy fields have been converted to sugarcane and similar crops, which are water hogs basically. So they take out 3 times more groundwater than paddy would take. So what is the outcome? Well, the outcome is that this comes to the cost of severe groundwater exploitation. So for the last 20, 30 years, climate change yet. Maybe future times, but not yet. So the main trigger for this groundwater depletion is possibly human. Well, when I say that, if therefore it's groundwater, let me introduce you to something else. And what something else is the rivers. And people think, most people think, that rivers like surface water and the groundwater these are two separate entities. But we, the people in the water domain, we know that they are not. And we have this new concept of one water that is coming through. But we think that the groundwater and the surface water actually are in continuum in most places. And this is also true for the mega rivers of the country. That's includes the Indus, the Ganga, and the Brahmaputra. I'm showing you the results of one of our more recent study from the Ganga Basin, and showing you with these photographs that I've taken, back in 2016, 17 years, where you see that people are actually walking on the Ganga. So in the summertime, it's a fact that parts of Ganga dries out. Now people think it's just a accident, just something has happened upstream, and it is drying out for a day or two. Maybe the dams, maybe the climate change, maybe the glaciers, who knows? But then we did a pretty thorough study, including all of our geological and hydrogeological techniques that I told you earlier, and we found out that actually it's not, because Ganga, to a large extent, from the middle reaches to the lower reaches, are actually groundwater sustained. So if you have a mass balance equation where the inflow is the groundwater, which is keeping the Ganga alive in the summer days, if you take the groundwater out of the picture, the river is going to dry out. It's simple mathematics. And this cartoon that you are seeing here kind of demonstrates that from the 1970s to 1960, how you can see that as the groundwater level came down, the Ganga river water level also came down. So we have our independent measurement, by which we kind of demonstrate that. And we also did mathematical modeling to show that by 2016, more like 2010, parts of the eastern and southern reaches of the Ganga actually have what we call a flow reversal. While instead of the Ganga receiving the groundwater in the summer days, it is actually the groundwater is taking over the river water. So it's a blow of two ways. First of all, the river is not getting its share of the groundwater. Second of all, the river water is now attracted toward the subsurface. And this happens, this is happening. Consequently, there is no doubt that if this goes on, the Ganga might be dying. Now, I told you just the example of Ganga. This is also true for Indus and Brahmaputra. And of course the southern rivers too. And our recent estimate, like as of last month, it shows that all of the subcontinental rivers are actually drying. It's not just the Ganga. And it's a calamity that is we are foreseeing. So we calculate now that by 2050, if we have a status quo and we don't do anything, that more than 100 million people living in the Ganga Basin would be facing food insecurity. Okay, now I'm not here to scare you all and create a doomsday picture. So let's talk about something positive here too. Okay, what we can do. Now, like I told you, that while those are things to be cautious about, but there is also a good thing that we did see government replenishment. And I bring that map again, where we showed that there are these western and southern parts of the country where we did see government rejuvenation. And when we do, take a measurement from the ground data, that field data, I again bring out that bilateral map, where we do see this pink and the blue dots, where we do have, substantial groundwater level increase. Now, let's focus on two areas for the next couple of slides. This is one area in Assam, Andhra Pradesh, now Andhra Pradesh and Telangana, and Gujarat. And let's see, for example, in both these areas, as you can see, there is a cluster of these pink to blue dots. So let's see that at least in these two areas, groundwater has rejuvenated, which is in contrast, like I said, to many what we believe that Gujarat is drying out and Telangana is drying out, having a drought. Yes, there are droughts, but the groundwater level is increasing. So what are the causes? Well, it's a policy intervention. Now, this policy intervention, at least in 2017, were not always planned. Now, 2017 onward, we had this Jal Shakti mission as a fallout of this project and some other works. But till 2017, either by the government agencies or by the local farmers or local residents, people were doing rejuvenation of river beds. They were, ducking out recharge canals or infiltration ponds. And in the backyard, people were doing rainwater harvesting. Now, in some places, it was a concerted effort, knowingly. In other places, it was just something they were doing. And consequently, what has happened, that groundwater recharge has happened in these areas. What we did find out, not exactly explicitly covered in this presentation, the government had this flagship program called the Manrega. Many of you will be knowing this. And what we did find out, just about 2016-17, that in the last 20 years, the Manrega program has actually immensely benefited, if nothing else, the groundwater. Why? Well, the thing is that in the Manrega program, one of the jobs that brown-skinned laborers will do in the 100 years work scheme is to dig ponds. Now, they dig ponds for various reasons. One of the reasons is to just hold the rainwater. But what they did, maybe even not knowingly, these rainwater harvesting ponds actually became the groundwater focus groundwater research structures. So when we presented this work, to the highest administration, they took it very positively, and there was a, to my understanding, change in the structure of the funding of the Manrega program, and much of the Manrega fund is now given to pond digging. Just augment the groundwater harvesting in the country. Now, there are two other things that need some mentioning, and one is the large-scale management structures. Again, you have large hydro management plants coming out, and some of these has huge catchment areas. Now, they have a lot of bad things, but they also have a lot of good things. The good things is that many of the times these large-scale hydrological management structures did a lot of recharge in adjacent areas. But one thing that stands out is an example for Gujarat. And there is a lot of debate on this, but I'll just tell you what we found out. So Gujarat, as you know, there was one of the most water scarce parts of the country. It still is. But in 2003, the then Chief Minister of Gujarat, the present Prime Minister, his government decided that people in Gujarat and the rest of the country, they do this irrigation by electricity, and electricity is either cheap or free in many parts of the country. So the farmers took advantage of that, and they pump out the groundwater without any caution. I mean, there is no restriction. There was no restriction. So what they did is they initiated something called the Jyotigram project. And this Jyotigram project in 2002-2003, they instituted, instead of one power grid, two power grids. One for residential areas where power will be supplied 24 hours a day to the houses and industries that are running. And there is another power grid which was explicitly kept for irrigation practices. And these power grids would have only power for 8 hours a day. So in a sense, they rationed the power supply. And that caused, like, instead of 24 hours a day pumping, it came down to 8 hours a day. Now, like I said, there is a lot of debate between the economists and the sociologists and the political scientists that whether there is a benefit of that or not. We are scientists, mathematics scientists, so let's go look at the mathematics. So we simulated this policy in a large hydrological model. And okay, this diagram is a little complicated. Let me just run through this. So this solid red line that you get to see is the groundwater observation trends over the last 20 years in 2014. And this blue line is a simulated lines. The satellite is this lines. What you do see from 1996, there was a dip. I mean, this trend was continuing from the 1970s actually. And by 2001, 2002, when this Rotterdam project was initiated, you see there is a change, and the change is quite prominent. And it actually came back to the 1996 or pre-1996 level. And our conjecture was that this restricted agriculture and electricity usage actually reduced the groundwater pumping, consequently the groundwater increase in these areas. So, in conclusion, we can say that the groundwater storage conditions in India in the last decade or in the past 2 decades actually has very diverse patterns. You can see that given take 13 cubic kilometers of groundwater is vanishing from India every year. 13 cubic kilometers. Whereas about 3 cubic kilometers of groundwater is coming back. But they are not coming back in the same place. So, just like I have been highlighting, the North Indian plains are dying out, but there are South Indian and Western Indian parts of the country where actually there are positive scenarios. So our work got highlighted in the NASA website, and what you can do see that the same maps that I showed you in the NASA color coded, the brown is the areas where you have intense groundwater depletion, and the green to blue areas where you have storage gain. Consequently, there was a lot of media highlights, and I think that somehow we were able to outreach our outcomes to the mass as well as the policy makers. If somebody is interested, you are welcome to take a look at this new book that came out from Global Groundwater, where India has a dedicated portion, and I'll be happy to take questions. Thank you.
Thank you, sir. Thank you for the talk. Now we will proceed with the questions if anyone has any.
So in view of time, we restrict one or two burning questions, and then yeah.
I think maybe first we can give chances to get, and then I'll.
Love.
Your mic is on.
I have question like, what is the actual cause of arsenic contamination in groundwater around Gangetic Plain?
It's the sediments. The arsenic is coming from the sediments through various hydrogeological processes, and then it is proliferated by human practices. So it's very much geological.
Yes, sir. Next question is, actually southern part of Bihar is suffering from arsenic and fluoride contamination mostly.
Okay.
So how can we remove arsenic or fluoride contamination in a small level? Means if we fill up bucket of water and so how can we?
So just to revise your statement, southern Bihar only has fluoride, not much arsenic. Only Patna area has some arsenic, but mostly fluoride. But yeah, the question is very relevant. So there are a lot of filters, either community scale filters where the government is investing a huge amount of fund in setting up community scale filters, or you can use a home filter, not the filters that you see in the TV ads. There are other filters which are possibly more easy in terms of the chemistry, how it works, where you can use them for either arsenic or fluoride removal. It's technically they are not very complicated, but of course you have to have it. And one of the reasons that the problem is still persisted across much of South Asia and more major parts of the world is that people either cannot avail it because of the cost and everything, or they are not aware of it. So the technology to remove the pollution from the water, at least for the geologic pollution, is not that complicated. Emerging pollutants are a different again, but arsenic and fluoride you can remove it.
Next question, sir. In that area, at which depth we should put a bore well or hand pump?
Sorry, I didn't follow.
Means at which depth we should do bore
It
well.
depends on actually it depends on the local geology and the hydrogeologic structure. So if you are in the Gangetic basin, you can get groundwater at a depth of 10 meters. Whether usable or not, that's another question. But you can get it. But in southern India, if you go, that you have to go for 100 meters.
So, but at shallow depth, there is contamination of groundwater at that area.
Actually not. So if you are at the shallowest depth, you don't have pollution. It's there's a mid-range where you get the pollution. So the dark wells don't have the pollution. Okay. So again, like I said, it depends on the geology and of course the usage. So if you are just using it for domestic purposes like bathing and taking a bath or something, the shallow water is good enough. Of course, it can have other pollution, but not arsenic or fluoride.
Yeah, of course. If you want to discuss further, sir will be here for the whole day. Please find some time. Go.
I think I'll
Okay. Okay. So in that case,
Manya also lunch visit really behind church and really church.
okay.
So now I'd like to call Professor Pankaj Kumar sir to felicitate Professor Chatterjee with a gift as a mark of appreciation from our institution.
Professor Liquid.
Thanks.
Thank you very
Thank
much.
you so much, sir, for coming here. It was a pleasure having you. Now, I would like to move on to our next segment. So, our next segment is lighting presentations. So, starting off with the presentations, as a first presenter, we have Arun Kumar Dubey. You have only 3 minutes, so please don't exceed the time.
Yes.
morning to respected teachers and everyone. My name is Arun Kumar Dubey. Now I am going to present a small video on my topic poster presentation. And my topic is 3D CRS Velocity Radial and Isotropic models of Northeast India and Western. Actually, mainly in this work, I have done the surface of tomography of 200 kilometers depth. So, actually, my study region is Northeast India and Advanced region, in which three countries seismic station have been used for the study purpose, which has been operated from 1994 to 2016. And here in the study region, inverted triangle is my seismic stations and different color stations have been shown nearby. So for this study reason, I have taken epicentral distance, that is epicentral distance range 2 to 20 degree, that is regional object, which have magnitude is greater than or equal to 4.5. Actually, for this surface tomography study, I have used the Rollinson and Sandridge code for surface tomography till 100 kilometer depth. So after the for the data validation, we have done here Raypath distribution where for both Rayleigh and Lambda tomography, and after Raypath distribution, I have also done the checkerboard test for the reliability of my model. So this checkerboard test have been done with 568 regional object, which have significant values greater than or equal to 2.5. So this checkerboard test has been done at 1 degree cross 1 degree. So for the day after data validation, actually after multiple filter techniques, I have found the Rayleigh group velocity and Love wave group velocity tomography, and then CR wave group velocity, CR wave tomography till the 100 kilometer depth. And after these results, actually I have also taken the 5 cross section in the study area. So that five section process shows the shear velocity and radial anisotropy results here. So from actually complete the log and relevant group velocity, we can see the my main result showing that when we are going the lower crustal to the upper middle part, we are getting actually high velocity in the Himalayan and Indo region, and when we are going to the southern crustal part, we are getting the lower velocity. So actually, this result showing the crustal material flow from the mid to lower crustal material flow from southern crustal to the eastern Himalayan axis, which have been stopping by the Sichuan basin. Here we are getting the high. And from these 5 profile, actually my main result showing the extension of Indian plate up to the BNSA, Bangam Indian. And I conclude because there is no limited time. So I have used the Rollinson and Sandridge FMSC method. And my main result is showing the crustal material flow and weak upper crust in southern people and Himalayan people and weak medium crust in the Lhasa and weak lower crust in Kanda. Thank you.
We'll not take questions now. The questions can be asked during the poster session. So you have a poster, right? If you are, of course, you should visit his poster. That's the reason of this live. Right. You should say, the speaker should say to, invite people to visit your poster.
So for the next presentation, we have Gaurav Kumar.
very good move earlier. So my name is Gaurav Bhatt, and I'm PhD student at the Provisional of the So my topic of the presentation is geographical insights into the evolution of South Pacific in the Shillong region. This is just a study of granites with some variety in place. And moving on to the background, this is the general geological stratigraphy of Shillong Plateau, and you can see there are multiple granitic programs here. The focus of the study is the South Pacific from the stages new project to automation, and I have chosen this project because of the direct interface which is on the and this is the zoomed in map of South Pacific. So these are the granite in the picture, and these red boxes and these black circles are showing the sample location from the tree I collected from. And these are the field photographs I collected. So this is showing the coexistence of dialectic images and the granites around the place. Going on to the objective of this study is to get the geological setting and pattern disease of this granitic group and the recent existence of dialectic in place to understand the better evolution dynamics of the slum granite. The methodology I have used is biblical sampling followed by the census interpretation and the sample preparation for geometric analysis. So I have used SRF for measurement data and ICDMS for measurement data, and I combined all the data to get the result in conclusion. These are the cartographic images. So the post grains are showing the inclusive nature of these rocks, which is mainly quartz, calcite, and moscovite with the general composition of the granites. And then we have some outdoor texture, interroad texture, or dynamic elevation, and some alteration in the rocks. Going on to the results, I have started with this eye plot. So you can see the red color is diorite and granites. So if we see the LA by B ratio of these two rocks are almost similar, which is showing the full magnetic nature of these rocks. And we can see the granites are mainly investment in LREs and completion in HREs, and some actually almost very conspicuous European anomaly. So if we move on to some more plots, we can see this first plot is showing the rock composition, which is from mapping to calcium infiltration. And talking about the granites, these are mainly A-type granites, specifically A2-type granites of the continental origin. And these granites are mainly enriched mantle source, and these are fractionating into these granites, and these granites are mainly having a technique of very great granites. So if I will detail talk about the composition of items from this city, mainly these dialects are mainly from the English mental source, and the granites are mainly K2 type granite, as I have already discussed, which are having enrichment of LREs and depletion in HREs with conspicuous negative. And based on the RE patterns, we can say these are co-magnetic nature. So most of these two rocks are almost similar, or we can say dialectic memories are nature. So the tectonic regime is very organic to post colonial art settings on national styles of dialectic minor. Please direct us. So, thank you.
Gaurav, you like
You
to
are almost, you are also welcome to questions or any questions or discussion. I am there. Thanks.
Yeah, and you can ask questions in answer also. So for the next presentation, we have Rohan Bhattacharya.
they can perhaps use this mic only, it will save time. ठीक है. Thank you, Gaurav, for adhering to the theme in the last slide. Please, Gaurav, yes. Good, well done.
Good morning, everyone. My name is Rohan Bhattacharya, and I will be talking on the topic of conservation and systematic in the North Desert. The mineral industry is one of the most abundant atmospheric loads in the global climate, and globally it emits more than 2,000 metric tons per year. And the immediate source of those dust are the paleochannels, dry liquids, and the arid and subarid regions. Hot desert is one and only hot desert in our country, which has ample source of those mineral dust. So, hot desert also witnessed northeast as well as southwest monsoon, And depending upon the direction of the prevailing winds, it has regional climate variant. It can influence the variant terrestrial biogeochemical cycles as well as the melting of glaciers in Himalaya. There are some recent studies developed on the remote sensing studies. They actually very useful on tracing the mineral dust from the source regions. At the same time, it also underscores the dust dispersals in the pre-instrumental era. We have utilized strontium as well as indium isotopic ratios to characterize hot desert and its dust outflows across the season. Uh, I have also attached one video clip from which you can get the area of the research I have taken, and that will be my concluding remarks.
Thank you so much, Rohan. With this, we are ending this lightning session. And for the next segment, we have SOS presentation by our BSMS fourth year student, Arya Palika. So I invite Arya on this stage. Good morning, everyone. I'm Aya, and I'll be talking about carbon sequestration in the solid rocks. Few of my seniors have already presented on it, but I would like to add on to my perspective to it. And someone like me who doesn't really have any research experience is so fascinated by this project. Following yesterday's Anthropocene decision, we collectively agreed that humans have an impact on global scale phenomena. Humans are a source. Humans are a force that can control things which happen on global scale. And whenever we think about those things, they are mostly destructive. It is how we are destructing our Mother Earth, how we should not do a lot of things that we have been doing, how we should not use fossil fuel, how we should not use plastics. But my genuine question was, there are a lot of don'ts to it. What can be done to to undo whatever the damage we have done? And with that philosophy and with that idea, I find this particular project, the idea of carbon sequestration, to be very interesting because it is a culmination, it is a geological answer to an environmental phenomenon. Starting off with what is carbon sequestration? When I first got introduced to this topic, I could imagine one thing that we are basically sucking out carbon dioxide out of the atmosphere, we're dissolving it, and we are dumping it underground. That was my very first idea of this project. So But then after studying more further about it, I figured out a lot of things that I'm going to share today. The very first few questions were how can it be done? What can be done? Where can it be done? And all these questions I will be asking in this presentation. So, firstly, let's see why it is important to restore the emission. Why it is important to get rid of the carbon dioxide in the atmosphere. We are very well versed with the figures that I'm projecting here. It has been discussed. So, after industrialization, which is mid 19th century, carbon dioxide emission have increased rapidly. About 2000 gigaton of carbon dioxide was released into atmosphere. And per year, the global temperature is increasing, greenhouse gas effects. We are well versed with that. So let's come to how can it be done? Now, carbon sequestration can be done in different processes. More than processes, I would like to emphasize it as to be different locations where carbon dioxide can be stored. And the very first one, it is better illustrated in the diagram, I would say. First one is the institute type of storage, where carbon dioxide is basically dissolved, formed into carbonic acid, and then stored underground. The second type of storage technique is ex situ, and as the name suggests, it is done on the surface. It is not done underground. It is done on the surface. And the good part about extractive type of carbon storage is that many of the industrial waste, such as the cement or the cement, that is used as an alkaline feedstock that can be mixed with concentrated CO2 and something productive such as carbonated concrete, which can be used for construction, can be built out of it. And the third type, which is the superficial type of sequestration. In this type of sequestration, you're mostly mixing alkaline feedstock and the carbon fluids, ambient CO2 that can be said. Very commonly practiced techniques is actually sowing or spreading the alkaline feedstock into the agricultural land or near the sea coast, which helps in carbon dioxide fixation. Okay. This is the mechanism by which the capturing or the sequestration happens. We try to uh, combine carbon dioxide with water and we form carbonic acid out of it. From the carbonic acid, we get from carbonic acid we have bicarbonates, and bicarbonates upon ionization gives hydrogen and carbonate. The hydrogen which is released from the bicarbonate is used as acidic water, which then combines with the silicate minerals and breaks down them. The larger cations such as Mg plus 2, Ca plus 2 or Fe plus 2 are released, and those larger cations then combine with carbonates to form a carbonated rock or a carbonated mineral. The commonly formed carbonated minerals are calcite, dolomite, and so on. Now, the problem with it is we cannot just mix the fluid of the carbonic acid with any rock. We cannot control that kind of reaction. So we have to make sure the rock that we are introducing the fluid into has certain minerals. The minerals being wollastonite, phosphorite, serpentine, anorthite, and basaltic glass. Okay, so why do we choose basalt for the sequestration process? The very first part is it has all the required minerals, the mafic minerals which are required for the fixation of carbon dioxide. Again, basalts are very widespread in nature. We can see the Deccan cracks The Deccan Traps in India covers around 60,000 square kilometers of area and sufficient volume for enough carbon dioxide to be stored. Other than that, it has all the minerals. Basalts have high quantity of mafic minerals, which means more of the cations are available for the reactions. And so it has good mineralization capacity compared to other silicate rocks. Um, Again, low risk of leakage due to rapid carbonate mineralization. As we would see, it doesn't take a decade or centuries for minerals to crystallize. It is only a part of a couple of years it takes to crystallize minerals. Ultramafic rocks are perhaps more suitable because they have more mafic content to it. But the problem with ultramafic rocks is that they are not readily available. They are scarce. So yeah, and another good point was good reactivity of pyroxene because pyroxene is a mineral which is not very stable. Pyroxene, olivine, these are not the minerals which are very stable on the surface of the earth. So they are highly reactive. They react with the carbonic acid to give you the minerals. Okay. Now this was all a very conceptual journey, but do we have any success stories? Is it actually happening? Is it possible? So yes, it is possible. It is happening around the world. The very good example of it is the Carfish project, which is a company which has executed this concept into reality. It is located in Helishhead, southwest of Iceland. It has a per annum sequestration of 30,000 to 40,000 tons of CO2. The target storage is located at a depth of 400 to 800 meters, and it basically takes the CO2 out of the geothermal fluid extraction from the reservoir. And not only CO2, the reservoir basically transmit a lot of other gases as well, which are methane, nitrogen, hydrogen. But we separate CO2 out of it and dry separately, and then we try to condensate it and remove and separate carbon dioxide out of it. Carbon dioxide, when fixed, is then dissolved into water and injected into the surface where the basalt or the mafic minerals are present. When stored underground, it reacts with the minerals and it reacts with the minerals and carbonated and sulfide minerals are then precipitated. According to the latest update into the Carbfix project, the atmospheric carbon dioxide is also directly captured into the system. So far, it has been only capturing from the direct source, but now they have started capturing from the atmosphere as well. So, yes, that's it. Thank you. If you have any questions. Thank you, Arya, for the enlightening session. Now, let's make our afternoon more interesting by playing a game for today using our geological mind. Let's play Geo World. I'm calling on Noor to hand over the mic to me.
this time we have introduced a new game, GeoVerta. So this will be interesting for all of you. So let's talk about the rules. What will be following. So these are the rules of the game. So like it is like you are seeing on the right hand side we have some blocks and there are some words. So like we will be sharing you some blank boxes and there you have to put some earth science words. So
Use the mic, huh?
hello, am I audible? Yeah, so this will be our game. So like when the data will appear green, it means it is in the right position. And if it is yellow, so you are in the wrong spot. So this should be in the another spot. Like here are the five boxes, and this data should be in any other box. Okay. So this will be following in this way. We will be getting 6 chances and to guess 5-letter word and 7 chances to get a 7-letter word. Like we will be increasing difficulty from 5 letter to 7 letter. For the first round, we will be having 5 words of 5 letters, which will be within 2 minutes. Whoever will be guessing the maximum number of words will move to the second round. And for the second round, we have kept 7-letter words.
We also share the answers within 2 minutes.
Yeah, so like also the result will be beyond 2 minutes will not be considered. So you have to guess it as quickly as possible.
And then send it to the email ID.
Yes.
Oh बाप रे, बहुत
There will be
complicated कर दिया तुम लोग.
there will be an option to share the results once you are correctly done. So after that, you'll have to share the
Then I'm not playing. Writing emails is too much.
No, sir, just share and write the Gmail. It will like every automatically start.
This is the link where you have to go to join.
Please type.
How to join? Using mobile?
Yes, sir. Using mobile.
Click onto this link and then you will
How
get
do I
the box.
click on this
Actually,
link?
sir, you have to type.
You have to-
Yeah, I agree. That's why you have to use this. Please type the link and tell us. We'll start the.
Now we can do this AI, na? Or
Sure.
So you should have added one QR
QR.
code.
Oh.
see, we can do this. Start with camera. And then what we can do? Search the light. Right. Yes. See?
I'm starting the timer.
Let everyone.
Okay, then what I have to do? The word is connected to the exploration of physical properties and phenomena of celestial objects. Let me sit with Ashish or my team here.
People will need more time. We have to wait, I think so.
I
टू मिनट और ऐड कर दे
सेंड कर दो
2 मिनट और ऐड कर दे
then we can. I will share the. What is that? कल हिट नहीं पाया हम लोग ना.
चेक और साइलेंट शेयर करो hits from research you have to guess the word. There will be right position and right word, right letter.
ग्रेविटेशनल टाइम एक बार स्टार्ट हुआ था. अच्छा ये सेम जगह पे लिख के जाना है. फिर क्या करना है? You are wrong. Yes. एक ही नहीं हो पाया यार.
have to input the second link on
Second another link.
इसका स्क्रीनशॉट भेजना है ना तुम्हें वो अनाउंस कर दो कि जो हुआ है गेम उसका स्क्रीनशॉट भेजना है क्या डायरेक्ट शेयर ही कर
Yeah, the word is
You people will tell us the answer also.
Yes, sir.
This is the third one. No. How many do you have?
5 or 5 letters. I think ବେଶୀ ଲୋକ ରହିବେନି.
There are multiple.
But yes, थोड़ा ज़्यादा है वो. Don't you agree? It's a bit more complicated.
You have to play the word.
The words are simple. It's like an extended.
Yeah, this is because you are not playing mobile. See, they got it. Head, they got it.
But that's not.
And they are getting bored from the students.
Can you change the word?
Yeah, sorry.
Can you change the word?
अरे
अरे 1 मिनट 27 सेकंड. सर ग्रीन नहीं हुआ. वो नहीं है.
मेल करना है
What is the email ID?
20197. Nita Rani 20.
Water in yourself. Who says that? Sir को ब्लड का Mission movement of quality. Water will what you want? You should do this. You should get it. No, I mean, if you are putting pressure on it. Index होता है. Yeah. Seven better. कितना राउंड है? How many rounds?
आप लोग सब कर उसके बाद
Seven.
Environment heavy तो हो रहा है. Art science नहीं है.
नो ऐसा बोलने में नहीं होता.
मैं कर नहीं पा रहा हूँ. I know, but you know I'm not winning. That's the problem. कोई भी जियोलॉजी का क्वेश्चन क्या है, सब सिर्फ एनवायरमेंट। हाँ, क्या सर? Done? Answer?
The first word was space.
hint was cosmology and all that. And you could have related it.
You can go on this revolving around.
I was thinking of radiation.
Too long.
Related to radiation.
And this is epoch.
को खेलना चाहिए.
This is ozone. This is river.
कैसे यार?
Distribution and the movement.
That's related. I mean, it's the
related to कितना कुछ हो सकता है, ocean भी हो सकता है.
That you have to guess the word.
The study of water is not river study of water.
No, sir. That is not the. It's just a hint. You have to find a word related to it.
So it should be then only related to water, not related to study of water. Related to water.
Good.
recycle.
Recycle.
Sustainability तो नहीं होता. Recycle कैसे आता है? और वो जो रिवर वाला है उसका आंसर एक्चुअली एक्वाटिक होना है.
5 letters.
Letter में 5 letters. 5.
This is wetland.
कोई बात नहीं.
Yeah, that's right.
And this is sandwich.
Sandwich.
SALVAG.
I thought sandwich.
Salvage does not necessarily include repurpose. Salvage means you take out, bring out whatever. But whether you want to repurpose it, if you are talking about repurposing, then it is about recycling.
Salvage is not a very, technical term, to be honest.
Recycle is the appropriate answer.
You use it everywhere.
And that is also
How many people got right answers? I want to know.
The second round, we almost answered 2 words correctly. For the first round, there is similar.
So the feedback is where people can answer more, it is better. More participation we will get.
So who got all correct? The first round?
That is what I am saying. Okay.
Thank you so much, everyone, for this mind-wrenching session of Wordle. Now let's move on to our main event, that is lunch.
How do you say that it is main event? The today is not at the lawn, it is at the upstairs.
Okay, so the lunch is at upstairs, so everyone is let's go to the upstairs.
Oh, Dhania is there. Anyway, हम लोग थोड़ा ये प्राइस को थोड़ा देख लेते हैं. Ajab, guys, who are taking care of the evening's prize distribution? Event management team. You are there now. Jitin, you are there also. Come, let's take out. Make sure that we share links as well. Jacob,
Please come back here by just okay, maybe 10 minutes before 2, okay? Just here. You can here.